Keeper 1.4, integration by parts. All right, so just a little review on your integration by parts. You want to use this to find the integral when there's really nothing else to do. So when it's like in the form of a product, you want to try to use your integration by parts. All right. Now again, you always still want to check like U substitution, trig power rules, trig substitution, whatever. You want to try all that first. But if you can't, go ahead and try integration by parts. Now remember, the way that you choose your U for integration by parts is our LIATE. So LIATE, remember, stands for logs, inverse trig, algebraic, trig, and exponential. So whichever one comes first in your expression, that's how you know which one is going to be your U. All right, so example 1, we have x to the 6 times ln 3x dx. Since I have an algebraic, which is x to the 6, and I also have a logarithmic, which is ln 3x, I have to choose my u to be the logarithmic. So u would be ln 3x, where dv would be x to the 6 dx. So once you set up your u and your dv, then you want to find your du and your v. Du is going to be 1 over x dx once simplified. And then v is going to be x to the 7 over 7. So now using my formula uv minus the integral v du, I have x to the 7th over 7 ln 3x minus the integral of 1 over x times x to the 7 over 7. Again, that was just me simply plugging into my formula. All right, so now cleaning that up a little bit, I have x to the 7 over 7 times ln 3x minus, I'm going to pull out the 1/7 and then reduce down my x's to be x to the 6. All right, so now when I integrate that last little end piece, I have x to the 7 over 7 ln 3x minus 1 over 7 times x to the 7 over 7 plus c. And lastly, I'm just going to clean it up totally, make it look really good. So I'm going to have x to the 7 over 7 ln 3x minus x to the 7 over 49 plus c. All right, so example 2, we have the integral of x squared sine pi x dx. And so I have an algebraic of x squared, and then I have a trig of sine pi x. So that means my u is going to be algebraic, and my dv is going to be sine pi x. Now, because u is algebraic, remember anytime you have an algebraic u, you can go ahead and use the table. So with my table, I'm going to set it up with u dv. I'm going to work the u side down, starting with x squared, and then I'm going to work that down to 2x, then 2, then 0. And then on that dv side, I'm starting with sine pi x, and I'm integrating down. So I'm going to have sine pi x, then negative 1 over pi cosine pi x, then negative 1 over pi squared sine pi x, or lastly 1 over pi cubed cosine pi x. Now remember, when you set up your table, you have to alternate your signs. So we always start positive and then alternate positive, negative, positive, negative. All right, so once I have that table, remember we're going to work the diagonals. So you're going to have, for instance, you're going to have x squared, and that's going to go to the one diagonal from it. So it's going to go to this 1 over pi cosine pi x. And then this 2x, we're going to make it negative because, again, we're alternating the signs. So negative 2x goes to the negative 1 over pi squared sine pi x. And then positive 2 is going to go down to this one, which would be positive 2 times 1 over pi cubed cosine pi x. And I just wrote it a little bit neatly when I wrote my final answer. All right, so example 3, we have the integral of x squared arc sine x dx. And so again, I have an algebraic of x squared, and then I have, it looks like an arc trig of arc sine x. So our u has to be arc sine x based off of LIATE, and dv is going to be x squared dx. So next I'm going to find my du, which is going to be 1 over the square root of 1 minus x squared dx, and then v, which is x cubed over 3. Plug in into my formula, I'm going to get 1/3 x cubed arc sine x minus 1/3 integral of x cubed square root 1 minus x squared dx. And again, I pulled that 1/3 out from the dv. All right, so working that integral to the right, I'm going to go ahead and do a simple u sub. And so I get u equals 1 minus x squared. And so du over 2 equals x dx. Now notice I have an additional x squared in my numerator, so I'm going to write that as x squared equals 1 minus u. And so when I work that integral, everything else stays the same, but my integral is going to become 1 minus u over the square root of u du. Now splitting that integral up, I'm going to have the integral of u to the negative 1/2 minus u to the 1/2. And then integrating that, I'm going to get, and I'm just referring to the integral piece of it, I'm going to get 2u to the 1/2 minus 2/3 u to the 3/2. Notice though I had pulled out the 1/2 earlier, and that's how my coefficient became 1/6. Alright, so cleaning that up a little more and substituting my u back in, I'm going to end up with 1/3 x cubed arc sine x plus 1/3 square root of 1 minus x squared minus 1/9 1 minus x squared to the 3/2 plus c. Alright, so next example, we have the integral of e to the x sine x dx. We're going to let u be sine x and dv equal e to the x. And so my du is going to be cosine x and v is going to be e to the x. Plugging into my formula, I get e to the x sine x minus the integral of e to the x cosine x dx. And then I'm going to integrate that integral piece again. And again, because it's e to the x and cosine x, I'm going to have to use integration by parts again. So I'm going to let u be cosine x, dv is going to be e to the x dx, du is going to be negative sine x dx, and v is going to be e to the x. Plugging that into my formula, I get e to the x sine x from before. And then using the new stuff, I get minus e to the x cosine x minus integral e to the x sine x, and it should have a dx. Alright, so remember that's what our original integral equaled. So our original integral equaled e to the x sine x, and on the right side I got e to the x sine x. So I can add those to each other. I can add it to each side of the equation. So I'm going to add integral e to the x sine x to both sides of the equation, which is going to give me 2 integral e to the x sine x equals e to the x sine x minus e to the x cosine x. Alright, so then to get my original equation back, I'm going to get the integral of e to the x sine x. I'm going to divide both sides by 2 to get e to the x sine x minus e to the x cosine x over 2.